Thank you for inviting me to give this short presentation. My name is Justin Gassas, and as I said, I'm a contractor that supports the Open Innovation Program that runs sites that supply a lot of NASA's data to the public. And today I'll try to give a brief tour of the NASA data universe. So first up in this talk, we'll give a summary of the various websites that the Open Innovation Program runs. Next, I'll talk a little bit about why there are so many different sites that you might go to in order to find NASA data. And I'll talk a bit about how data is harvested from the smaller sites to some of the larger sites, and there are a range of different open NASA sites. Tips on searching for data, and one example from the current NASA Space Challenge. As I mentioned before, I spent part of my time supporting the Open Innovation Program, which is run out of NASA's Office of the Chief Information Officer. Is concerned with agency-wide open sharing of public data. Open.nasa.gov is a central page for information engagement that crosses the four other sites. It is general information about how NASA fulfills open government mandates, as well as some news and blog post type things. API.nasa.gov is a pass-through service that we use to promote several NASA APIs. We currently have 17 active APIs listed on this site, including astronomy picture of the day, near-Earth objects, and a couple different Mars rover. Code.nasa.gov lists all the code projects that have gone through the official NASA software release process to be made public. And so we currently have 555 open source projects that are listed on code.nasa.gov. Data.nasa.gov is one of the largest, most successful sites with nearly 20,000 unique visitors per month and more than 40,000 different data sets. A small percent of these are actually hosted directly on data.nasa.gov, but most of them exist on different data sites and are just linked to from data.nasa.gov. The Open Innovation data sites come together through a large number of people. The core team is quite small with 2.5 developers, and I'm like half because I split my time between this and a different project. Most of the work is actually done by the dataset suppliers and administrators of the other NASA data sites that push their datasets to data.nasa.gov. Additionally, one of our sites, API.nasa.gov, as well as code.nasa.gov, are actually managed and run from public repositories on github.com, where we accept issues and pull requests from the general public. In the next section, I'm going to talk about why there's so many different websites that hold NASA data and how they all kind of fit together. So this is my why so many sites slide. It could be like whole presentation in itself, but I try to kind of condense things here into like kind of 3 parts. So there's like 3 competing forces that tend to create all these different sites. First, the US Congress and the White House play a role by creating mandates that specify data and code must be released to the public in certain ways and certain sites called certain things, and harvestable from those sites to other larger sites. Second, a lot of NASA data is actually created by, analyzed by, or in some way connected to grants given to university scientists and labs. And it is very common for those science grants to come with strings attached that say that data sets created in the process of doing that science has to be placed in specific science archives that are specific for that science field. And then third, a lot of this data doesn't exist as isolated data files by itself, but is actually created or sometimes consumed by other programmatic things, which means it has to be put in places and put in forms that allow those tasks to be fulfilled. And so create some of the smaller sites you might find around. So additionally, many NASA sites that host data have harvesting relationships with one another. So in general, more specific data hosting sites, smaller ones, get harvested up into larger, more general data sites, with the last one at the end of the chain being data.gov, which currently has 236,000 data sets. So although theoretically all the data sets should exist in data.gov, some of them don't get harvested up, so you won't find everything just by searching in data.gov. And also, it's worth noting that sometimes it's actually simpler to find things if you search on sites that just hold a certain type of data set because the search interfaces on those specialized sites are built for that type of data set. This next slide is titled Domain-Specific NASA Data Site. So I have here a small selection of domain-specific data sites. Sites 1 through 6 here are for specific types of science data. So these are some of the science archives I've mentioned previously. And then sites 7 through 9 are for documents, studies, patents, reports, and regulations as well. And then 10 and 11 on this list hold Earth imagery and climate data, which is produced through collaborations between NASA and USGS, which is the United States Geological Survey, and NOAA, which is the National Oceanographic and Atmospheric Agency. And so because some of those data products are produced through collaborations between NASA and those other federal agencies, you have to go to those other federal agency data sites to find those files sometimes. And then in the next section, I'm going to talk a little bit about some tips for finding NASA data sets. So first, the most often used data sets are typically the simplest ones to work with. So the ones I'm showing on the slide here are the most used ones from the open innovation sites. And a point of this is that when you're searching on data.nasa.gov, the default behavior is when you search for a term, it'll give you back the files that most closely match that term. But you can actually sort those results a couple of different ways, including sorting them by which of them were downloaded the most often. And I find that can sometimes be a very good way to get the results you get back from data.nasa.gov. Second, starter code is a great way to get things done quickly. A lot of you have to figure out how to download data, filter NASA data, and process it. If you can find someone's code and how they have already done the first few steps of a project, that can potentially save you a lot of time. Just searching through github.com with NASA as a search term will give you a lot of stuff back. Just searching for NASA itself on github.com will give you over 10,000 different code repositories that are tagged with NASA somehow. There's also a datanauts.org on GitHub that is a bunch of people that work just with NASA data. So that's another good one to check out for examples, as well as to help you think about what type of project to do. And then the box in the lower left corner has a site that a member of the public built, which lets you search through all the past projects for space apps. If you're working on a space apps challenge that was also used in past space apps, looking at what other projects have put together can give you some very strong clues of how you might work on the project that you're going to build. And then on the right-hand side of that slide, I've got some links to 2 different web pages that host a lot of live and forkable on JavaScript code. So both of those pages have search functionality in there. So there's starter code here that will help you work with a lot of NASA data sets, potentially really shorten the time required to work on a project. And then more abstractly, it's worth considering what type of search you're doing. You could either already know a certain data set exists, in which case you're more finding in your search, or if you do not know what data sets exist, but you kind of want to find out what sort of things are available within a certain concept. So those are kind of 2 different types of searching. For the finding case, where you know a type of data set which is called a certain thing almost certainly exists somewhere, data.nasa.gov is a good place to start, as it relies on string matching. So if you know a data set has a term in its title and you know that data set probably exists, that's a good way to find it. However, if you don't know what data sets exist in connection with the challenge, you might consider instead going to a site with data on that topic and exploring around. That way you're more likely to stumble upon something that you didn't know existed in the first place. Slide 18 kind of builds on the previous slide. A data set like data.nasa.gov has a large diversity of data, and so it's better for string matching in terms of finding things. Something like the Mars Weather website or the Mars Weather API, it's better to go to a web page just for that topic. And then some comments on open innovation specific sites, api.nasa.gov. It's worth pointing out again that api.nasa.gov doesn't host every single NASA API. It just hosts the simplest ones to get started with. And so you can find lots of other NASA APIs in other places. And data.nasa.gov can sometimes be a good place to find additional, slightly more complicated APIs. And then for code.nasa.gov has most of the things on github.com/NASA, but it doesn't have every single project. And likewise, GitHub doesn't have every single project that's on code.nasa.gov. So it's worth checking in both places, not just one. And then for data.nasa.gov, it's worth noting that file formats, when you go to the search page for data.nasa.gov, there will be a sidebar that will have things like file format, tags, and types. Those things are all metadata populated by people. And so a lot of times people won't actually populate those tags very well. So if you click on a tag, you won't get back every single data set that might match that theme or that topic. It'll just be the things that people have actually tagged by hand with that topic. Don't think if you click on things in CSV format, you will get back every single CSV file. You will just get back a selection of them that have been human tagged as a CSV file. I have one example here going through one of the NASA space apps. So the challenge was you were on an astronaut or robotic mission lead tasked with bringing back specimens from the moon to Earth so you could study them further. So you have to evaluate lunar samples quickly and decide which ones to keep, which ones to not bring back. The task is, how do you distinguish between valuable samples and non-valuable samples? So this Space Apps Challenge has been posted, has some example data sets that's really good, and I would suggest starting there. But some other suggestions is that it's probably always a good idea to spend a small amount of time looking for the organization pages of NASA groups that do work related to that challenge. So there's sometimes different groups, different centers with slightly different names that work on similar stuff. So if you search for Moon Rocks Johnson Space Center, you'll find out that the name of the group that works on that type of stuff is called the Astro Materials Group. And so they have a database, it turns out, of every single moon rock that was brought back from the moon. That might be a very excellent database to use as far as this project. And then also, you might want to search for papers or description of past NASA studies that are very closely related to the challenge. So this challenge is all about sample selection. And so if you go to SDI, which holds scientific papers that NASA has published, and you search sample selection, one of the top results you get back is this paper called GeoLab Concept Importance of Sample Selection During Long Duration Human Exploration. So it's basically what a lot of people have put down in this scientific paper that very closely relates to this NASA Space Apps Challenge. So these are really good things to spend some time going through to learn about how people at NASA have thought about and worked up potential solutions to these types of problems.